So today we are talking about systems with no solution. So if I'm given the system that's in front of me here, and I would like to solve that by hand, like we've been practicing, I would really like to get some opposite coefficients on some of those variables. So I need to decide which letter I would like to get rid of first. I'm going to choose the x in this problem. So I'm looking at the 5 and the 10, which I'm thinking to myself, what is the number that 5 and 10 both multiply to? And in this case, the answer would be 10. So if I could get that to 5 to be a 10, that would be perfect. Well, remember, we can't change just one thing in that equation, so I need to change every single thing in that equation. In order to get that 5 to be a 10, I would need to multiply everything in that equation by 2. Now remember, my goal is to add these equations together and get either the x's to go away or the y's to go away. Since I've chosen the x's to go away, I would really like one of these to be a positive 10 and one of them to be a negative 10. So instead of multiplying by 2, I think I would like to multiply by negative 2. So I need to go ahead and multiply everything in that top equation by negative 2. That'll give me negative 10x plus 8y equals negative 2. Now the bottom equation did not change at all, so I can just recopy that one right underneath. And now I'm looking at my system and I'm looking for those opposite coefficients. Well, I see one, it's right here. Negative 10x and 10x, if I add those up, they would equal 0. But wait a minute, I see another pair. I see opposite coefficients also on the y's. Now, I'm not going to worry too much about that right now because I just want to see what happens when I add these together. What is it that happens? Maybe something special will happen. Negative 10x plus 10x is 0x. Negative 8y minus 8y, let's see, that would be plus 0y. And negative 2 plus negative 30 is negative 32. So 0 times x is 0, 0 times y is 0. So it looks like what I'm getting is 0 equals negative 32. And you're probably thinking to yourself, what the heck, what the heck? Miss Ring, I think you made a mistake because that doesn't make any sense right there. Well, I didn't make any mistakes. This is what happens when we have a system with no solution. When we actually solve it, we get this crazy answer that doesn't make any sense. So this is an example of a system with no solution. Let's see what happens if I take the same system and I go ahead and I write each of those equations into slope-intercept form. And if you don't remember what slope-intercept form means, it simply means get the y by itself, right? That's what we've learned so far. So I would really like to, I'm just going to scoot this equation over here. 5x minus 4y equals 1. And I need to get the y by itself. So I need to move this 5x over to the other side. Since it's positive, I'm going to subtract 5x to move it over to the other side. So I have negative 4y, don't forget to carry that sign down, equals 1 minus 5x. And now I need to divide everything by negative 4. Every single thing. So my negative 4's cancel on the y, and I'm just left with y. I'm going to leave everything in fraction form. So I have negative 1 over 4, and a negative 5 over a negative 4 is a positive 5 over 4x. All right, so that equation, the y is by itself. Now I need to take that bottom equation, and I need to write that one by itself. So let's see. I started off with 10x minus 8y equals negative 30. I need to move that x again over to the other side. So since the 10x is positive, I need to subtract it to the other side. All right. Now what I get is negative 8y. Don't forget to bring your sign down. Equals negative 30 minus 10x. I would really like to get that y by itself, so I need to divide everything by negative 8 still. And again, I'm going to leave my answers in fraction form. So I get the y by itself because the negative 8's canceled. I get negative 30 divided by negative 8 is a positive 30 over 8. And a negative 10 over a negative 8 is a positive 10 over 8x. Now, if I take a look at those two equations here, the one in red, I'll highlight them for us here, and the one in blue, if I take a look at those two equations, is there anything that they have in common? Well, at first glance, I'm looking around, well, they both have an x, they both have a y, but other than that, they look like they're different. They don't have any of the same fractions, nothing looks like it's the same. But I'm going to take these two equations and I'm going to look a little bit further. So I'm going to take this equation that was in blue and I would like to simplify those fractions. Remember, I want to put them simplest form. So 30 and 8, I'm thinking, what is a number that I could divide 30 and 8 by? Well, I can divide both of those by 2. So 30 divided by 2 is 15. 8 divided by 2 is 4. And then I can think the same thing on this other fraction, 10 and 8. Those can both be divided by 2 as well. So 10 divided by 2 is 5. 8 divided by 2 is 4. So now I have this new equation here, y equals 15 over 4 plus 5 over 4x. Now if I compare those two equations, these two equations, I can see, oh boy, they have the same rate of change. They both have 5 over 4x as their rate of change, but their starts are different. The green highlighted one, that start is negative 1 over 4. The other one is 15 over 4. So they have different starts, but the same rate of change. Let's see what that looks like on a graph. So here are my two equations again. This one here, the top one was in red. So my start was negative 1 over 4, which is about right there on the graph. And now I need to rise 5 and run 4. So rising 5, running 4, put my other point, and draw my line. Okay, so that one's done. The top one is done. Now remember the bottom equation here, we rewrote that one. We rewrote it in simplest form. So we had y equals 10 divided by 2 was 5. So y equals 5 over 8 divided by 2, which was 4. 5 over 4x. 30 divided by 2, that was 15. And 8 divided by 2, that was 4. So there was our simplified equation. Well, 15 divided by 4 is 3.75. So I'm going to put that point on my graph here. And then I need to rise 5 and run 4. And now I need to draw that line in as well. And hopefully we notice something about these two lines here. Is there anything special that we're noticing about those two lines? Well, hopefully you're looking at them and you're saying, those lines don't cross. And if you remember what we talked about with systems, a solution on a graph to a system is always where those two lines cross. These lines don't ever cross. So what we get are parallel lines. So if a system has no solution, that means that the lines on that graph are going to be parallel. They'll never, ever, ever cross. So just to recap, if we put a system that has no solution on a graph, we'll end up with parallel lines that do not cross. If I write my system in slope-intercept form, what we get is two equations here that have different starts but the same rate of change. Different starts, but the same rate of change. And then if I solve that system by hand, I get this wacky answer that doesn't make any sense at all. So that's how we know whether or not a solution has no, or a system has no solutions. If it has no solution, those are our results.